Hello and welcome to my science tutorials. In today's video, we want to look at what collinear points are. Alright, so let's begin. Now, if we look at this diagram, we have some lines that are joined in a pattern to form this four squared shape, and then we have another line from the middle A to C. Now, there are some points on this line, so we see point A, B, C, D, E, F, and G. Now, let's now define what collinear points are. Collinear points. So when we talk about collinear points, they are points that can be found together on a straight line, or they are points that lie on the same line. So it means if I take, let's say, line AB, I can see point A, point G, and then point B on that line. So the points A, G, and B become my collinear point because they can be found on a straight line. Now if I look at A, E, and C, that is also another straight line, and there are 3 points on it. So I also have A, E, and C. These are also collinear points. If I look at the line, let's say D, F, and C, they are also collinear points since we have all those points on one straight line. B and C are also collinear points because they are points on a straight line. So B and C, the same way we have A and D are also collinear points. So basically, collinear point is just you have a straight line, you have points, let's say A, B, and C on it, they become collinear point. Now if you have two lines joined together and one point is here, one point is here, let's say this is D and this is X. Now these 2 points are not collinear points because they are not on a straight line, but they are on different lines, so they are not collinear point. Now let's look at how we determine whether some points are collinear or not. Now there are 3 ways to do that. The first one is to use the distance formula, which is what we'll be looking at in today's video, and in the subsequent video we'll be looking at the other ways of calculating collinear points. The second way to do that is to use the slope formula or the gradient formula. And then the last way of doing this is the area of triangle formula. But like I said, for the purpose of this tutorial, we will be looking at the distance formula. Now, for the distance formula, if let's say we have point A, B, and C, let's say this is a straight line, we have a point, let me use a different color. So we have a point here A, another point here B, and another point here C, and this point A, B, and C are said to be collinear. Then it means the distance AB plus the distance BC should be equal to the distance AC. So I take that again. So if the point A, B, and C are collinear, it means the distance AB, so AB here, and then the distance BC, if we add the two, it should be equal to the distance AC at the bottom over here. Now we know that to calculate the distance of 2 points, let's say A and B, this is equal to the root of the coordinates s2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula, and this is what we'll be using to calculate what collinear points are. Alright, so with this basic introduction, let's go ahead and look at some questions on collinear points. So we have to find if the points x, y, and z are collinear given their points -3, -1, -1, 0, and 1, 1 respectively. Alright, so let's write down our solution. So we have the points x with the coordinates -3, -1, and then we have the point y with a coordinate -1 and 0, and then we have the last point z, +1, +1. All right, Now we were asked to find if the point x, y, and z are collinear. Now because we are using the distance formula, it means that if the point x, y, and z are collinear, then the distance of xy plus the distance of yz should be equal to the distance xz. So it means the distance from the point x to y and the distance from the point y to z should be equal to the distance from x to z. Alright, so let's look at how to calculate that. So I'll do it step by step. So let's calculate the distance xy. So the distance xy is equal to, and we have into bracket, s2 minus x1 squared plus y2 minus y1 squared. Now let me label my coordinates. So this is my x1, y1 in this case, and this is my s2, y2. So that means that I have over here my s2 is -1 minus my x1 is -3, so it becomes -3 here squared, plus plus my y2 here is 0 minus my y1, which is -1, so -1 squared. So this becomes -1 minus -3, that will become plus. So -1 plus 3 will give us 2. So I have 2 squared here, plus this is +1, -1 is +1, and then +1 squared over here. So I'm going to have 2 squared is 4, and then 1 squared is 1. So I'm going to have √5 as my answer over here. So the distance xy is √5. Alright, so let's go ahead and calculate the distance yz. So the distance yz is equal to, I have root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so in this case, because we are starting with a point y and z, then this now becomes my x1, my y1, this becomes my s2, my y2. So this is equal to the root of my s2 is 1 minus my x1, which is -1, so -1 squared, plus my y2 is 1 minus my y1 is 0 squared. So this is equal to 1 minus -1 will give me 2, because this becomes plus, so it becomes 2 squared here plus into bracket 1 squared, and this is equal to 2 squared is 4 plus 1 squared is 1. This gives me √5 as my answer. Now this is √5, this is √5, so it means that just before we calculate the distance xz, it means that √5 for xy over here plus yz, which is also √5, this will give me 2 √5 as my answer. So I'm expecting that my distance xz will be equal to 2 √5, and if that is the case, then I know that my 3 points x, y, and z are collinear. Alright, so let me go ahead and calculate the distance xz. So I'm just gonna erase this and this guy. Okay, so the distance xz will also be equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So the distance xz will be equal to, now because my x is the first coordinate over here, my first point over here, the coordinates here become my x1, this becomes my y1, and because the second point is z, this becomes my s2, y2. So I have over here the root of x2, which is 1, minus x1, which is -3, squared, plus my y2, which is also 1, minus my y1, which is also -1 squared. So the distance xz is equal to the root of 1 minus minus 3, that will give me 4. So 4 squared plus 1 minus minus 1 will give me 2 squared. So I have over here 4 squared is 16 plus 2 squared is 4. And if I add this, this will give me root 20. Okay, and root 20, you can solve it as basically this is like 4 multiplied by 5. And then the root of 4 is 2, so you bring that outside, so it becomes 2 root 5. So this is our answer. We have 2 root 5 as our answer. Because the distance xz is 2 root 5, and then the distance xy plus the distance yz is also root 5 root 5. If you add, you get 2 root 5. It therefore concludes that the points x, y, and z are collinear. Alright, so let's have a look at another example. We are to show that the 3 points P 24, Q 46, and R 68 are collinear. Alright, so let's write down our solution. Now, for us to show that the points P, Q, and R are collinear, it means the distance between PQ plus the distance between QR should be equal to the distance PR. Alright, so I'm going to do this straightforward. So the distance PQ will be equal to the root of s2 minus x1 squared plus y2 minus y1 squared, then plus the root of same thing, x2 minus x1 squared plus y2 minus y1 squared to be equal to the root of s2 minus x1 squared plus y2 minus y1 squared. Now when you're doing this, be very careful not to confuse the coordinates of your point. Alright, so let me take PQ first. Yes, P and Q. So let me do that first. So if I do that, this becomes my x1, my y1. This becomes my s2, my y2. So this will be equal to the root of my s2 is 4 minus my x1 is 2 squared plus my y2 is 6 minus my y1 is 4 squared. Now plus, okay, so I can go ahead and erase these guys. Okay, now I'm at QR, so that will be equal to the root of, for QR, this becomes my x1 y1 s2 y2. So my s2 is 6 minus my y1, sorry, my x1 is 4 squared plus my y2 is 8 minus my y1, which is 6 squared, is equal to the root of, okay, so now I carefully erase this. Okay, I can maintain that. So this will still be my y2. This becomes my x1, my y1 now, since I'm using P and R. So my s2 is 6 minus my x1, which is 2 squared, plus my y2, which is 8 minus my y1, which is 4, now squared. So this becomes the root of 4 minus 2, that will give me 2, so it becomes 2 squared, plus 6 minus 4 will give me 2 squared, plus the root of 6 minus 4 will give me 2 squared, plus 8 minus 6 also give me 2 squared. This is equal to, then I come to this side, 6 minus 2 will give me 4 squared, plus 8 minus 4 will give me 4 squared. So I have over here 2 squared plus 2 squared, so this will give me 4, this will give me 4, and that will be root 8 at this point. So I have over here root 8 plus this will also give me root 8 is equal to, this side will give me 4 square is 16 plus another 4 square, which is also 16. So that will give me root 32. And then root 32, say this is root 8 plus root 8 is equal to root 32 can be written as 4 multiplied by 8, because 4 multiplied by 8 will give me 32, and I know the root of 4 is equal to 2, so this becomes over here root 8 plus root 8 is equal to the root. This will become 2 squared, so it will take care of the root, so it comes outside 2 root 8. So we can see that root 8 plus root 8 is equal to 2 root 8. And because PQ plus QR, which is root 8 plus root 8, is equal to 2 root 8, we therefore conclude that the points P, Q, and R are collinear. Now, if you look at it very well, over here, this can also be your answer, but we try to rewrite it in a way that it is easily visible for you to understand. So you try to rewrite it to have the same number under the root, so root 8, root 8. So you try to convert your root 32 to root 8 so that it can be easily identified. So over here we have root 8 plus root 8, so this side will give us root 8. So let me do that. So root 8 plus root 8 will give us 2 root 8, and this is equal to this side, which is also 2 root 8. So we can see that the left hand side is equal to the right hand side, and so the points P, Q, and R are collinear points. So thank you so much for watching, and in the next video we'll be looking at how to calculate collinear points using the gradient or the slope formula. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at collinear points using the slope or the gradient formula. So without further ado, let's begin. Now, in our previous video, we did look at what collinear point is. We said that collinear points are any point that can be found on a straight line. So assuming we have this straight line, so let's say we have a point here, say point A, we have another point here, point B, and then another point here, point C. We say that these 3 points are collinear points because they are found on a straight line. Now, to be able to identify if 3 points are collinear points, there are 3 different ways we do that. We can either use the distance formula, which we saw in our previous video. The second way to do that is to use the slope or the gradient formula. And then the last way to do that is to use the area of a triangle approach or formula. Alright, so in this video, we'll be looking at the second part, which is the slope or the gradient formula. Now, if 3 points are collinear points, it means that the gradient of any of those 2 points should be the same. I take that again. If let's say the points A, B, and C are collinear, then the gradient of any of these 2 points should be the same. So it means if I calculate the gradient of, let's say, point AB, it should be equal to if I calculate the gradient of point BC, and it should be equal to if I calculate the gradient of AC. So if the gradient of AB is 1, then I expect the gradient of BC to also be 1, and then the gradient of AC to also be 1. Alright, so this is how we find whether 3 points are collinear or not. Now, just a little recap. To find the slope or the gradient of 2 points, which is given by M, this is equal to the change in the y-axis, which is y2 minus y1 over s2 minus x1. So this is basically a change in y-axis on the change in x-axis. So this is the formula for calculating the gradient of a line of any 2 given points. Alright, so let's look at an example. We are to show, using the slope formula, that the 3 points P 24, Q 46, and R 68 are collinear. Alright, so let's go ahead and look at the solution to this problem. Alright, so they're saying we should show using the slope formula that the 3 points PQ, so I have P 2 4, my Q 4 6, and then R 6 8 are collinear. Now if these 3 points, if P, Q, and R are collinear, then the gradient of the point PQ, that is P and Q, if you find the gradient of these two, it should be equal to if you find the gradient of Q and R, and it should be the same if you find the gradient of P and R. Alright, so let's go ahead and find the gradient of each of these points. So the gradient of PQ will be equal to y2 minus y1 on x2 minus x1. So let me label my coordinates. So this becomes, since P is my first point, it becomes my x1, y1. This is my s2, y2. So my y2 is 6 minus my y1, which is 4, on my s2, which is 4, minus my x1, which is 2. So this gives me 6 minus 4 is 2, on 4 minus 2 is also 2, and this is equal to 1. So the gradient PQ is 1. Alright, so let's go ahead and calculate the gradient for QR. The gradient for QR will be y2 minus y1 on s2 minus x1. Alright. Now in this case, because now I am looking at Q and R, my Q becomes my first point, so this becomes my x1, y1, this becomes s2, y2. Okay, so it means that my y2 over here is 8 minus my y1, which is 6, on s2, which is 6, minus x1, which is 4. So this is equal to 8 minus 6, that will give me 2. 6 minus 4 will also give me 2, and this is equal to 1. So already we can see that the gradient of the point PQ and the gradient QR are already the same. So let's confirm the last one, which is the gradient of the points P and R. So the last one, the gradient of PR. So in that case, our gradient will be y2 minus y1 on x2 minus x1 as usual. But this time around, let me erase this. This time around, because we are starting, our first point is P, it means that this becomes our x1, y1. Alright. So from here, we have my y2 is 8 minus my y1 is 4 on my s2 is 6 minus my x1, which is 2 over here. So this is equal to 4 on 4, and this is equal to 1. So we can see that the gradient of the point PQ is 1, which is equal to the gradient of the point QR, which is also 1, and which is equal to the gradient of the point PR, which is also 1. So because the gradient of PQ is equal to the gradient of QR, which is equal to the gradient of PR, we say that the 3 points P, Q, and R are collinear. So you can end your question by writing this statement to show that yes, because this is 1, this is 1, and this is also 1, the 3 points are collinear. Alright, so let's go ahead and have a look at another example. So if A with the coordinate 5, 2, B 3, negative 2, and C 8, 8 are 3 points in a plane, check whether the points are collinear or not. Alright, so let's write down our solution. So you can go ahead and try calculating the gradient for the point AB, BC, and then AC to see if you will get the same answer for the gradient. Alright, so let's go ahead. So I'm going to write my point A 5, 2, my B is 3, negative 2, and then my C is 8, 8. As usual, I say if A, B, and C are collinear, then it means that the gradient of the points AB should be equal to the gradient of the points BC, and that should be equal to the gradient of the point AC. So the first thing I do is to calculate the gradient of my points AB. So for my point AB, this becomes my x1, my y1, my s2, y2. Okay, so my formula is y2 minus y1 on s2 minus x1. So this is equal to my y2 is negative 2 minus my y1, which is 2, on my s2, which is 3, minus x1, which is 5. So this is equal to minus 4 at the top on 3 minus 5 will give me minus 2, and this cancels this, so I have here 2 as my gradient over here. Alright, so let's go ahead and calculate the gradient of B and C. Okay. So for the gradient of BC, this is equal to y2 minus y1 on x2 minus x1. Because B is our first point, it means that this is my x1, y1, s2, y2. So this is equal to my y2 is 8 over here, as you can see, so I have 8 here, minus my y1 is minus 2, so I have minus 2, on my s2 is also 8, minus my y1 is 3. So this is equal to, at the top I'm going to have 8 plus 2, and that will give me a 10. On the bottom here, 8 minus 3 will give me a 5, and 10 on 5 will give me 2 as my answer. Alright, so let's go ahead and calculate the gradient of the last set of points, that is A and C, to see if we'll get the same result. So the gradient of the point AC is equal to, for AC, my A becomes my first point, so I have y1, x1, y1, and then x2, y2. Alright, so I can go ahead and quote my slope or gradient formula, which is y2 minus y1 on x2 minus x1. So this is equal to, my y2 is 8 minus my y1, which is 2, on my s2, which is also 8, minus my x1, which is 5. So I have at the top over here 8 minus 2, that will give me 6, on 8 minus 3, sorry, 8 minus 5, that will give me a 3, and 6 on 3 will give me 2. So therefore, we can conclude that the point A, B, and C are collinear since the gradient of any 2 points, let's say the point AB is 2, point BC is also 2, and point AC is 2. Since the gradients are the same, the points A, B, and C are collinear points. So thank you so much for watching. This is how we use the slope or the gradient formula to find if 3 points are collinear points on a straight line. Now in the next video, we'll be looking at how to use the area of a triangle formula to find if 3 points are collinear or not. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn how to find collinear points by using the area of a triangle formula. Now in our previous 2 tutorials, we did look at how to find collinear points using the slope or the gradient formula and the distance or the length formula. Now in today's video, we want to look at how to find if 3 points are collinear but using the area of a triangle formula. Now we said collinear points are 2 or 3 points that can be found on a straight line. So any point that can be found on a straight line, we said they are collinear points. So let's look at something. So assuming we have a straight line here, let me just draw a straight line. Assuming we have a straight line here and we have one point here A, another point here B with their coordinates respectively, another one here C. Now if you look at these 3 points, there is no way you can join these 3 points to make a triangle. No possible way. But what if, let's say we have point A here and then point B in a straight line with it, but point C is slightly displaced downward, so it's not in line with A, B and C, it's somewhere, let's say, slightly down here. So this is point A, this is point B and this is C. If this becomes the case, you see that you can join, okay, that is a terrible line. So if that happens, you can see that you can join the point A to B, B to C and then C to A to form some sort of triangle, whether isosceles, whether scalene or right angle triangle. You could form any type of triangle if one of the points is displaced. But if all of them are in straight line, you cannot get a triangle. So the whole idea behind the triangle formula is that if 3 points are collinear, then the area of the triangle should be 0 because they will not form any triangle. So we are not expecting any value for the area of the triangle. But if they are not collinear points, then we should get a value for the area of a triangle. So suppose we have the points, let's say P, which has the coordinate x1, y1. Then we have another point Q with the coordinate x2, y2, and another point R with the coordinate x3, y3. Now using these 3 points, how do we use the area of a triangle formula to show that the 3 points are collinear? We do that by using the formula half, then we have like matrices. We have x1 minus x2, then we leave room, s2 minus x3, then we have here y1 minus y2, then we have y2 minus y1, sorry, y2 minus y3 here should be equal to 0. So this is a 2 by 2 matrix. We know how to solve a 2 by 2 matrix to find a determinant. So all we have to do is to solve this formula as a 2 by 2 matrix, find the determinant and then multiply it by half. If we multiply it by half and we get 0, then we know that those 3 points are collinear points and hence cannot form any triangle because they are in a straight line. So this is the formula we'll be using to find if 3 or more points are collinear. So let's go ahead and look at how to use this formula in real time. So we have to find if the point P 2, 3, Q 4, 0 and R 6, -3 are collinear points. So let's write down our solution. Now we know that we are using the area of a triangle formula and not the distance or the slope formula. So this time around, I'm going to write my P with the coordinates 2, 3. I write my Q 4, 0, and I write my R 6, -3. So from here, I'm going to label my coordinates. This is my x1, y1, s2, y2. This is my s3, y3. Alright, so we know that if P, Q, and R are collinear points, then it means that half, then we have x1 minus x2, s2 minus x3, y1 minus y2, y2 minus y3 should be equal to 0 since they are collinear points. So all we have to do from here is to do our substitution. So we have half multiplied by our x1 is 2 here, minus x2 is 4, then s2 is 4 minus x3, which is 6, this is equal to 0. Then my y1 is 3 minus my y2, which is 0, and my y2 is 0 minus my y3, which is negative 3. So this will be equal to, I have my half outside bracket, then 2 minus 4 will give me a negative 2, then 4 minus 6 will give me a negative 2, then I have 3 minus 0 will give me 3, and 0 minus 3 will become plus 3. So I have 3 here is equal to 0. Now you know that when solving matrix X, 2 by 2 matrix, to find the determinant, you multiply the leading diagonal, which is these two guys first, and you subtract the other diagonal from it. So we are having half, then into bracket, we multiply the leading diagonal, so it will be negative 2 multiplied by 3 minus then the other diagonal, so it will be 3 multiplied by negative 2 over here, should be equal to 0. So I have here half into bracket, sorry, my matrix bars. So minus 2 multiplied by 3 will give me a minus 6, minus this minus 3 multiplied by negative 2 will give me a minus 6 again. And so this is equal to half minus 6 plus 6, and negative 6 plus 6 is 0, multiplied by half is still 0, so this is equal to 0. And so because after solving everything over here we get 0, it therefore means that the points P, Q, and R are collinear. They are collinear since the area is equal to 0, since the area of the triangle is equal to 0. Alright, so let's have a look at another example to further understand what we are talking about. So we are to show that the points A, B, and C are collinear using the area of a triangle formula. Alright, so let's write down our solution. As usual, I'll write down my points. So I have 5, 2 for A, B with the coordinates 3, negative 2, and C with the coordinates 8 and 8. So I'll go ahead and label my coordinates. So this is my x1, y1, my s2, y2, my s3, y3. And so I know that if points A, B, and C are collinear, and I'm using the area of the triangle formula, it means that half x1 minus x2, x2 minus s3, y1 minus y2, y2 minus y3 should be equal to 0. So over here I go ahead and do my substitution. So my s1 is 5 minus my s2 is 3, my s2 is 3 minus my s3, which is 8, is equal to my y1 is 2 minus my y2, which is negative 2. Then I have negative 2 as my y2 minus 8 as my y3. So from here I have half, then 5 minus 3 will give me a positive 2. 3 minus 8 will give me a negative 5. 2 minus minus 2 will give me a positive 4, since the negative negative becomes positive. And then negative 2, negative 8 give me a negative 10 over here. This is equal to 0. So I'm going to multiply the leading diagonal and subtract the second diagonal from it. So it will be, I have 2 multiplied by negative 10 minus then the adjacent diagonal 4 multiplied by negative 5 is equal to 0. So I have here half, into bracket 2 multiplied by negative 10 will give me negative 20 minus 4 multiplied by negative 5 will give me negative 20. So I have here half multiplied by negative 20, negative negative becomes positive 20. So this is half multiplied by 0 is equal to 0, and so 0 is equal to 0. Alright, so because the area of the formula, the area of the triangle after calculating is equal to 0, We can therefore conclude that the points A with the coordinate 5, 2, B with the coordinate 3, -2, and C with the coordinate 8, 8 are collinear points since the area of the triangle is equal to 0. So thank you so much for watching. This is how we calculate the collinear points to find whether the points, 2 or more points, are collinear using the area of a triangle formula. Alright, so I will see you in the next video where we'll be talking about the equations of a straight line given 1 point. So thank you once again, and I'll see you in the next video. Bye bye.